a new short video about setting up a Proxmox data center that we're going to do. Once again, as usual, we're running late for tomorrow. Why are we running late? Because when you prepare small projects like this, you'll see this small project is actually quite something. There are always little unexpected things, so we adapt and find solutions. We've found solutions for everything, which means tomorrow we'll be able to install. So in the end, compared to the last video you made about a year ago, we're actually ahead of schedule. The short video you made a year ago was filmed just an hour before leaving. So you see, this time we have 24 hours. We're getting better. In this video, we're going to look at a data center running Proxmox 9. I think, unfortunately, I said I would make one for you, but we never actually made a video about Proxmox 9 for you because we did not have the time to produce it. Anyway, here we're going to show you a bit of Proxmox 9. Anyway, the idea here is more to show you a bit of what we can offer your company, rather than to give you a presentation of Proxmox 9. So I'll start by giving you a bit of background on why we set this up. It's a training center. To tell you the truth, a year ago, it was already a training center. It was another member of the group, let's say, from the training center, who told us, well, we're very satisfied with the first data center you set up for us. Could you make us a proposal for another training center? As you can imagine, the answer was yes. So we made them a proposal, except that this time the context is slightly different. That probably hasn't escaped your notice. We have really big supply problems when it comes to memory RAM. And now, even storage is facing the same issue. Why? Because our friends, the AI fuzzers, are gobbling up all the memory stocks, and we end up with almost nothing left on the market. And so when, by sheer luck, you actually manage to find something, it's worth its weight in gold. So you see, it's not easy right now to offer you data centers, but we're still managing. In this case, we'll get there, but not really with the memory we had originally planned. Initially, we had planned to use ECC memory because, as you'll see, it's based on an MS, or rather on 4 MS-02 Ultras, and the MS-02 Ultra supports ECC. Well, yes, but you still have to find ECC memory. We can't find any, so the memory won't be ECC. It's not a big deal, especially since with a data center Proxmox, where precisely we've planned for redundancy, it's not a big deal not to have ECC, I was going to say almost. The data center will compensate for this little, let's say, technical detail. So the training center group, very satisfied with the first data center we offered them, ordered a second one from us. Pretty much the same situation, meaning there was already an existing infrastructure in place with, let's say, standard servers. I can't remember if they were Dell or HP servers, but in any case, originally they thought they would replace those servers with other servers. So we're going to buy HP servers, we're going to buy 2 servers, and then they'll be set up in failover with each other. Well, the first training center said that we already had a pretty nice solution, one that had been working well for a year. We never hear about any issues. Everything's fine. So meet Carpe Diem and you'll see that they have an alternative. So the alternative is the same as for the first training center. These are MS-02s, not MS-01s like a year ago. The MS-02s are really a step above in terms of quality, features, and power. Basically, they're just better. We have a dedicated video about this, so I'll let you watch it. I'll put the link just above. A bit more complexity here because these 4 MS-02s will be distributed across 2 different buildings with a fiber optic interconnection between them. So we'll have 2 MS-02s on one side with safe storage, which will be managed by stacking 2 10 gigabit switches. And the same setup on the other building, 2 MS-02s, 2 safe storage units with 2 TP-Link switches to name them specifically. So the question ultimately arose regarding this solution I just described to you. Where 2 servers, let's say legacy ones, 2 Dells or 2 HPs, are set up in failover, well, the client was given the proposal, he looked at the price and he said, oh, wow, it's much cheaper with your 4 MS-02s. You're offering me more resilience against failures, you're giving me greater storage and ultimately more memory as well. I can ensure smooth operation between my 2 sites. Remote, the 2 buildings which are therefore remote from each other. There's no comparison. Hands down, it's a better solution. So our client already had a much better financial situation at that level. And above all, we migrated them to Proxmox 9. instead of VMware. And as you know, VMware has really changed its pricing these days. And then in the end, it forces you to accept Broadcom's new rules, which means that license costs are a bit out of control these days. So when you consider the technical aspect, a much better robustness, much better resilience with 4 servers instead of 2 in failover mode, you see if it's not one, it's the other, with not necessarily an automatic recovery. And when you factor in that the price of all the servers is much cheaper overall, plus with no VMware license at the end, you have a solution that is more efficient, which is better at handling failures, and it's much less expensive. There you go. That's the hardware you see behind me. I'm going to take my little portable camera to do a quick voiceover while filming all of this for you. And then afterwards, we'll meet up again. For the end of this video, in front of Maxence's screen, which you've already seen in a previous video, to do a few tests on how it works and on failover. We're not going to spend 2 hours on it because watching a server failover for ages, honestly, isn't that interesting. Here, the idea is mainly to show you that it works, that it's effective. We might even simulate a failure. We'll see. And also to show you the equipment you can set up in your company. Come on, follow me. On the table, you can already see the 4 MS-02 Ultra units. By the way, there's a bit of noise, but actually, it's him who's making it. It's a switch that's fully 10 gigabit SFP plus, fully. Well, not completely because there are 4 Ethernet ports here, but it's the switch that's making the noise. And that's a shame because I could have let you hear, or rather not hear, that these the 4 MS-02s make almost no noise at all. Well, I say almost, it doesn't mean zero, but almost no noise. So these MS-02s are connected on one hand with the dual 10 gigabit SFP plus card, which is here. So this is the Minisforum card. And then we've added here, according to the client's needs, a QNAP card, which itself has 2 SFP plus outputs, so 10 gigabits. There you go. And here you have the 2 cards that will allow us to manage the safe across the 2 stacks. As I mentioned, there are 2 buildings. As you can see, we have a pair of network switches that will be installed in the first physical building location. And then we have 2 other switches that will be situated in the entirely separate second building. And 2 MS-02s like this will be in one building, and 2 MS-02s will be in the other building. And through the 2 outputs that are here, through trunks that are on the switch side, I won't go into all the details, but basically we'll be able to manage a safe that will operate across all 4. And what that means is, if we were to lose, for example, access to one building, you see here, this is the link, the connection between the 2 buildings. If we lost this connection, everything would keep working on one side. And on the other side as well, with, of course, the VMs that would be running on this side and other VMs running on the other side. Then when the connection is restored, the safe would rebalance itself and ensure that we have a safe that is synchronized between the 2 buildings. And then another scenario, if at some point an MS-02 were to fail, the VMs running on it at that moment, provided the other MS-02s are not too heavily loaded, would automatically migrate to the other 4 MS-02s to ensure continuity of operation. Well, there you go. I haven't anything else to show you here, except that we've installed a small OC200, which is a little controller. It's a TP-Link from the Omada range, so a controller that allows us to manage the 4 switches here to handle the VLANs, though I won't go into technical details here, but there are a lot of VLANs that need to be implemented for everything to work properly. Stable operation of all the different layers of Proxmox and the safe, and then there's an administration VLAN, that's it. And that's what will allow this training center, which has a little over 900 students, it's quite a large training center, to function. This was to show you, with what we're demonstrating here on a table, that ultimately, with much smaller servers that consume far less energy and are really much cheaper, today we have the ability to provide you with real technical solutions that allow companies to, well, that still have major requirements for availability to operate. All right, let's head over to Maxence's workstation.
Hello?
Maxence, as I mentioned earlier, you've already seen him in a previous video that was also about data centers, Proxmox, and so on. And now, Maxence, thank you in advance for your upcoming presentation. You're going to show us a few things. First, you're going to describe a bit about the environment we're in, what we saw earlier on the table, and then we'll do 2 or 3 little tests. We're not going to do dozens about migration and about a failure of one of the MS-02 units. In any case, we're going to simulate a breakdown. That's what I meant. All right, let's go, Maxence. Show us everything.
So as you said, we're running Proxmox 9. So we won't dwell on that too much, but there you go. That's what we used for the client's new installation. We set up a safe. The data is replicated 3 times so that in case of a failure of an OSD or a PVE, we can recover the data from wherever the VMs are on another OSD.
Just a tiny detail that comes to mind. As you'll see on the screen, we only have 124 gigabytes of memory installed across all the nodes or PVs. This is very temporary, as I mentioned earlier, but as you probably know, there's a huge memory shortage. It's very hard to find any. We found some last night, so it's very recent. And the client is leaving today with his 124 gigabytes of RAM, but he will have, I believe, 96 gigabytes per node, so 96.4 in a few days, which will be delivered to him. So this is really the first delivery that will allow him to test that everything is working fine. He'll get a bit of hands-on experience with all of this, so to speak. And then once the memory arrives, he'll really be able to start migrating things on his end. 2 VMs that were on VMware, now on Proxmox. Go ahead, Maxence. Sorry for interrupting you.
As I mentioned earlier, we've set up a safe. And so in this safe, we have 12 terabytes of storage. But what is actually usable is 3 times less, since we replicate everything 3 times.
And we have 96 CPUs.
We're going to take a quick look at the safe to show you a bit of how it all works. So right now our safe is in good health, as you can see here. So we didn't set up a metadata server, since that's related to SafeFS, which is for things like GNFS sharing or folder sharing, etc. And in our case, it wasn't necessary. So each time we set up 3 managers and 3 monitors to ensure redundancy, in case we lose one of the monitors or one of the managers. We can also take a quick look at the OSDs. So here we can see that for each PVE we have 2 SSD drives. Each SSD has a capacity of 4 terabytes. We chose SSDs for performance reasons. We can also see that they are currently not being used at all. But that's normal, since right now there's only a single test VM, so it's not fully set up yet. On the client side, we can also take a quick look at the configuration to see the performance of each OSD here. It is important to keep in mind that Proxmox will automatically give priority to the specific OSD that has been assigned the highest weight value. So which one has the maximum performance?
Why are the performances slightly different? Can that be explained?
Well, yes, but here we're between 61,000 and 71,000 reads and writes per second. So that can already be quite normal, given that there isn't necessarily any load, etc. And depending on the load and what's happening on each of the PVEs, the value can vary a little bit.
All right. Maybe we can move on to a quick migration of our test VM. If you could tell us a little about this VM, and then we'll do a crash, let's say simulate a crash.
It's a very small VM. It's an Ubuntu server LTS 24, really just freshly installed. As for HA, we can see here that failback is disabled. This is to prevent PVE4 from always being prioritized in terms of priorities. So, in the case of a manual failover, it also prevents the VM from returning to PVE4 once it has been migrated. So the affinity rules section. This is the change from version 9 compared to version 8, which managed HA with groups. Now today we manage it with rules, which is a bit more user-friendly. Here we can see that the priority of PVE4 is the highest, so that means it will prioritize PVE4 for running the VM. Next it will be PVE3 with 4 and so on. We also have resource affinity rule settings. So for our example, this isn't useful since we only have a single VM, but it allows you to have multiple resources that will either always be on the same nodes or always on different nodes. So depending, for example, if we have a cluster of web servers, these web servers that work together, we might not want them to always be on the same ones. PVE. So we would rather choose keep separate.
That's in version 9.
And that's specific to version 9.
Okay.
So right now the affinity rule is more about crashes and issues, and it's going to be used to prioritize based on the available PVEs. So what we're going to do now is a normal live migration, and we're going to choose, for example, PVE2. Basically, it's a standard migration.
And we will certainly try to demonstrate for you the specific moment when it begins its migration, but
it's very fast. It's on the order of about 10 milliseconds. There we go, migrate. It started at 26 and finished at 29. It didn't even take 10 milliseconds.
So here the fact is that it's extremely fast because, as a reminder, it's only migrating the machine's state and RAM. It doesn't migrate, let's say, the machine's disks, which are already in the safe.
So that's how a normal live migration works. And what we can do is switch back to PVE4, so we're in the classic scenario where it's the one with the highest priority.
So I'm going to go over to the PVEs to unplug the fiber cables because, as you saw, the safe communicates via fiber optics, and this will simulate a failure. And now we'll see what happens with this famous VM. All right, let's meet over there, and Maxence will stay here to accompany you. So we're going to unplug both fiber optic cables here. We'll just disconnect them from the back, one and then the other. I have the fibers in my hands, Maxence. I fear this is a serious moment, and we might have a little problem with this VM, or maybe not.
So indeed, since you just unplugged it, we can see that PVE4 is no longer responding, which is perfectly normal in this specific case.
Could you please take a moment to explain to us exactly what the entire process entails? What specifically causes this PVE to be detected as malfunctioning? And what the consequences are as a direct result of this?
We have implemented and configured a specialized hardware watchdog system that effectively allows the individual cards themselves to constantly monitor and determine whether the corresponding remote card is actively responding or if it has encountered a failure.
All right.
Depending on that, they can determine whether it's just a fault, for example, with one of the fibers or something like that, or if it's also a software crash that would cause the PVE not to respond, not because of the hardware, as we might have here, but because the software is simply stuck and forces a remote reboot of the machine.
Okay, got it. There.
There are some periods that cannot be shortened for bringing the machine back into service. The first period that can't be shortened is the watchdog waiting time, which is about 60 seconds. This time is to make sure that the remote PVE which had the machine is really no longer responding.
All right.
And so on Proxmox, this time cannot be compressed. And then the second critical period of time that simply cannot be shortened or reduced in any way is the specific amount of time that is required to block all write access to the safe, and then successfully carry out the full migration process of the VM.
All right.
This takes roughly between 60 and 90 seconds. So in the best case scenario, if the timing is right, we can have a restart in about 2 minutes. 2 minutes, 2 minutes, and 30 seconds.
All right. So we'll speed up this part a bit so you don't have to wait. 2 minutes and 30 seconds, of course.
The VM has just migrated, and so there we go. We'll wait a few seconds for it to start up since it just migrated a moment ago.
Yes, because there's no magic involved either. Let's just say that since it was in the middle of communicating, even though the storage is preserved, they're in the Ceph. But as for the writes, we kind of stopped them, let's say, stopped them abruptly, all of that. So inevitably, the VM has to reboot at some point.
There we go. It's starting up.
To fill a bit of this startup time, I would say that in this kind of situation, what we're mainly aiming for is, in a way, the DRP, the disaster recovery plan that we managed to have, or high availability, we can call it whatever we want, even though they're not exactly the same things, concerns these famous resources, which in this case is a virtual machine or a virtual server, but inevitably we're dealing with a failure scenario. Now here, it's not really a failure of the PVE or the MS-02, it's the fact that we unplugged the fiber optics, but for the system, it's the same thing. In the end, since the PVE is no longer reachable, nor is the storage, in short, all of this impacts the machine, but ultimately, it ends up restarting on another one. So you experienced a brief interruption that imposed the unavoidable timing constraints, etc., plus the reboot time. But in theory, you have a machine that afterwards restarts, since we will have it in its last state, in a way. Except for the writes that were in progress, obviously.
Well, that's where it gets stuck. A little bit, since we're on a network that's not connected to the internet, the network part is a bit of an issue. Problem. That's why the VM... But it took a little while to start up, otherwise it would have already started.
We're going to end this video like this. We'll just show you the moment because I see that there's a timer running with no limit. So maybe we won't wait for the no limit. There you go. The machine is pretty nice. It's still starting up. In the end, the no limit didn't happen. And now there you go. It's asking to log in. So that's how we're going to end this video. What we just wanted to show you here is that in the end, with a 4 MS-02 installation, plus the fiber optics, plus the backup, plus the... Did you see all that? You could have a real data center. There was no requirement to have servers. Big servers, I won't mention any brands so as not to offend anyone, but big servers from major institutional manufacturers, and we have something very efficient here that frankly costs much, much, much less. And in these very complicated times, especially with RAM prices that have been skyrocketing since September 2025, it's not insignificant to have the possibility to save a little in that area, infrastructure, while ultimately strengthening the availability of your information system. That's it. Thank you, Maxence,
For
your demonstration and your 2 or 3 insights about Proxmox 9. I think we'll make a more comprehensive video about Proxmox 9. Yeah, the idea was really to show it to you in action. Not so much to explain how it works, and especially not to go over all the new features, which are quite numerous. In version 9, as you can see, it's version 9.1.7. So we're no longer in a completely initial release. It's a version that has been thoroughly patched. Shall we reconnect the fiber optics just to rebalance our safe setup? To wrap up, maybe you could actually show the safe in the state where it currently is, of course. That is, right now it's missing a PVE. Before we deliver to our client tomorrow, we're going to put it back into service to ensure proper balancing. And when it arrives at their place, everything will be green. There you go. Thank you for watching this video. See you very soon for the next one. Don't forget to like, don't forget to subscribe. Leave us some nice comments. Let us know what you thought of this presentation. And feel free to share your experiences and feedback, whether it's with Proxmox or VMware. If you're thinking about switching to Proxmox, or if you have pros and cons to share, let us know. In short, don't hesitate to put all of that in the comments, and I'll see you again very, very soon.